So good afternoon. Welcome to the SolarSel first products presentation. It's from common sense that the majority of energy consumed nowadays are in urban environments. And so we need to think the energy production in a different way, and one possible choice is using photovoltaics in our buildings. A current solution now that we usually use is silicon photovoltaics on the rooftops. But if we compare the area available that we have on the rooftop and in the facades, we can see here that if we use these facades to produce electricity, we have here a great opportunity of take advantage of them. The problem is that we need devices able to produce, to absorb diffuse light, because they have to be positioned at the vertical. So what we suggest is why not we should use dye-sensitized solar cells on our facades, since the silicon photovoltaics have very low efficiency on the vertical. Actually, the dye-sensitized solar cells, with their ability of absorbing both diffuse and direct light, can have high efficiency at the vertical, under cloudy environments, and also even with artificial light. So even in your living rooms or a closed room with artificial light, we can produce electricity. If we imagine two buildings, one totally covered with silicon technology and another one totally covered, the facades, with the dye-sensitized solar cells technology, we can get more 40% energy in the building totally covered with dye-sensitized solar cells. So the question now is, if it is so efficient in the vertical, why it is not commercially available for the building integrated photovoltaics applications? And the question is, and the answer is quite easy, is because the current DSS technologies are only available for short lifetime applications like gadgets and electronics, because these devices only last for 3 years. And why? Because dye-sensitized solar cells are composed by two glass supports that we then have to seal and introduce a liquid electrolyte inside. And this liquid, with time, start to leak. So what we have developed was a low-temperature laser-assisted sealing that actually allows us to have the liquid electrolyte inside the cell without leaking for 20 years, and turning this technology available for building integrated photovoltaics applications. So this sealing is actually efficient and durable. So our product, the SolarSel glass, let me show you. This is our first prototype of the SolarSel glass. It can actually last for 20 years in order to comply to the photovoltaic standards and also to the building standards. It has multiple colors, different shapes of transparency, and you can print even a logo type here if you want to do publicity for your company. It is easily to integrate in the different glasses that you want in the facade, double glazing or laminated glass, and also with different metal profile systems. At the end, you will have a complete system with easy integration to the grid. In terms of economics, it's also very interesting. So, as a market, we decided to get in France and Germany, in Europe first, because these countries have legal directives. They will be more receptive to our product, and we expect to get 20 megawatt sales at the end of 2020 with an investment of 4.2 million euros with payback after 6 years. Our great team, interdisciplinary one from one of the best faculties of engineering of Portugal, and also EFASEC, and our executive João Claro, and also our MBA students. So at the end, do not forget, you can get a facade producing electricity. Thank you very much for your attention.